Can I get a book in for you?
Yeah, that'd be great.
So it worked out. So well done. So that's I figured.
Anyway, anything perfect.
Sorry, Nina. Nina Simone, really? No one?
Yes, you were just saying that.
Saying, man, come on. Nina Simone, no one do it? No one? Do it? That's awesome. All right. Happy post-celebration day, everybody. So happy we're all here together. Hello. Post-depression. Super Bowl. Post. Monday should be holiday. That's my new rule. Monday. Every Monday, not just Super Bowl. Monday should be holiday. Would you agree?
Yeah.
It's Monday.
Okay, so first announcement. We've got some intensives coming up. Yeah, consensus coming up some Fridays. Starting Fridays. Not this Friday. Maybe the next one, but I think the next one. So I think 2 Fridays from this Friday. We may have a date for that. I don't know. 24th? Okay. Friday the 24th will probably be an intensive day. What are intensives? Intensives are where we do a bunch of problems for about 3.5 hours straight, and we go over material that you're all supposed to know already. And then we're going to have verbal intensives starting up that week probably too. They'll be Wednesday, Thursday in the mornings. More to come. Probably by Thursday this week, I'll have details on that when I figure it out. Got it? Okay, cool. So, that's exciting. Anybody have any questions about anything in life?
Yeah.
Whoa. Yes.
What's going to be the format of intensive? Are you going to do like 1 topic a day or 2 or 3?
The format for intensives will be, let me make this up. This will be the format. The format's going to be like biochemistry intensive, a bunch of biochemistry passages, and then biochemistry content. So I'll teach and go as we go. So I'll probably read the passage and be like, look, you gotta know this, you're supposed to know this, you're supposed to know this. We'll take a bunch of notes and be like, I should know all this, and then we ask questions, and then we do the questions. So it'll be topic by topic. So there'll be a biochem intensive, a physics intensive, a GChem intensive, chem intensive, verbal intensive.
On the same day?
No, dude, like 2 a day. 2 intensives a day. 3.5 hours, starting 8 to 11:30, 12 to 3:30. I think those hours work for me. I think that's good. Yeah, that'll be what it is. Got it? So that'll probably be the intensives. Does that answer your question?
Yes.
Okay, good. Well, I'm on time. I just got one question to answer. All right, we got to do tonight. Tonight's like not all the little douchey, little, ew, I said this and I said this, little, everybody know what I'm talking about?
Yep.
Yeah, tonight's not the douchey night. Tonight's a fun night. We had to do a little bit of endocrine. Did we menstruate together last time or no? I forgot. No, I don't think we did. Yeah, so we get to menstruate together. We're gonna actually make babies tonight, so that's always fun. So we can make babies. Y'all are missing out at home. It's not as good on video, but in person it works better. So we're gonna make some babies tonight. We're going to, yeah, I said that. we're gonna make some babies. We're gonna do, what else are we doing tonight? What else is on tonight? I did it in that whole homework sheet. It says everything we're doing. Eyes and ears tonight. See, somebody read the homework sheet. Y'all know there's a homework sheet? It says everything we're doing. Believe it or not, there's a sheet that tells us everything we're doing in class. I kind of usually look at it, and I forgot to tonight. So we're doing, and I usually ask you guys, and then every once in a while, you guys totally screw me up. And you're like, oh, Scott, we're doing this tonight. And I teach all this shit, and you're like, it was the wrong homework sheet. And I'm like, why did you do that? So I don't listen to you guys. So tonight we're doing eyes and ears. We're going to do development, brain stuff, and some hormones. Okay, that's tonight. And then next time we do all our sociology stuff. Psych and sociology goes together. Yes, it's a homework sheet. If you don't have the homework sheet, send an email and say, please send me the homework sheet. We'll send you a homework sheet and tell you everything that's going on. Psych and sociology are the same section, dude. Same shit. Psychology, sociology is all the same nasty ass
We
stuff.
didn't have a homework sheet. Yeah, for. Yeah.
Yeah, you do. It's on the homework sheet. Yeah, look at the homework sheet. Look at the psych and social homework sheet. It says exactly the topics we're doing. If you got the homework sheet in the last decade, maybe. So yeah, send an email. If you don't have the homework sheet, send an email for the homework sheet. If you're perplexed by my question, send a freaking email and say, I'm perplexed, and you'll get an answer. Of some sort, maybe not the one you want. All right, let's make some babies. Let's make some babies real quick. So we're supposed to do development. Development's a part of psychology. I guess it kind of makes sense how you develop so they just throw it all in there. There's like, well, we're talking about developing personalities, developing this, developing that. What is it? Genetics, or is it? What's the old thing? Nurture versus nature. Who wins? Nature wins. Always. Why does nature win? Because you have the DNA or you don't. But what does nurturing do? It turns the genes on or off. So you should understand the argument of nature versus nurture, right? Nature is the what? It's your genetics. Can you overcome your genetics? Very difficult to. You can fake it, man. You can be an actor. If you're an introvert, you're an introvert. If you're an extrovert, you're an extrovert. Some introverts are the most excellent extroverts, but they're faking it. Got it? We're kind of programmed for those things. So the bottom line is nature versus nature. Nature, genetics is it, man. If you're not predisposed to do that, it's very difficult to overcome that stuff. Like what? Sleep cycle is another one. Sleep cycle. How many morning people in here? Evil people. Humans. What is that about? Who the hell who likes morning? The only good time morning is from the night before. Like, who the hell does that? How do you do that? Like, what do you do? Like, you get on I'm awake. Oh, I don't like you anymore. I thought I liked you. I don't like you anymore. Oh, what is a morning person, man? What is that? Really? Right or wrong? Like 3 o'clock in the morning is meant to become, that's the end of the day. 3, 4 in the morning, the sun comes up. It's like, oh, it's time to go to bed. Back into my coffin. I mean, seriously. Oh, okay. Like what's early? Allie, what do you got? 6, 7, 6? Yeah, my dogs are like, Papa, get up, walk us. I'm like, fuck you, dogs. Why do I have dogs? I walk, and I'm like, anyway. All right, so yeah, that's you should know that's genetically pre-programmed. The circadian rhythm is pre-programmed, man. So y'all morning people are just morning people. That's it. You can try and change it, but you can't. But tied to that is when you take your MCAT, what time is it? If you are not a morning person, you need to be a morning person for at least 5 or 6 weeks. So if you do not like mornings, suck it up and get up at 8 a.m., not 10 a.m., not 9 a.m., 8 a.m., and get used. And don't just get up at 8 a.m. and be like, I'm awake, Scott, and hit snooze. No, that's not what you do. You get up at 8 a.m. and you actually do something. I am telling you, you cannot be like, oh, it's 9:30. Oh, shit, I'm taking an MCAT. You can't do that. Do you understand? So I am telling you guys, if you are night people, the night people who are the normal ones, the night people, please start training yourself to get up at 8 a.m. and do verbal passages, do whatever, I don't care. And that's after your little Pilates or whatever else you eat in the morning, your Eggs Benedict, whatever the hell you people do. By 8 a.m., at least 5 weeks before your test, everyone in this room should be up at 8 a.m. doing passages. Got it? 5-6 days a week, man, without a doubt. She's like really? Ever? She's like, 8 a.m., I don't even know what that means. Yeah, are you a night person? Yeah. So the bottom line is, suck it up, because you can't have your brain. And believe it or not, you can wire your brain. You actually start to get the neurons thinking at that time. And once your neurons are comfortable, it's easier to think. Got it? So please do that. That is a major, major, major thing that you need to do. Clear? All right, so everybody get up early. I'm calling. I got you all your phone numbers. I'm calling you 8 a.m. No snoozing on me. Get it? All right, we'll do that. But at least Wednesdays and Thursdays, or Tuesdays and Wednesdays. I don't remember when verbal's going to be, but it'll be in the email that supposedly is coming. All right, let's do it. Let's make some babies and let's roll with this. So we got the beautiful uterus. Oh, what a pretty uterus. This is a little bit of an ugly uterus. And we're going to kind of fly through this because you should have seen it somewhere, somehow, or read about it, because I have a homework sheet that tells us why we're doing this tonight. Mo, did you see the homework sheet? All right. Good. We're doing it again. It's on the sheet. All right, but we're going to do it faster. So you should know all this. It's be easy. All right, so in the ovary are a bunch of follicles. What is a follicle? What is a follicle? Like, what is it? What is it? What is it? A primary oocyte is not a follicle. Houses. What is a follicle? Like, what is it? What is a follicle? A follicle is what? Exactly. That's a follicle. It's just a bunch of cells. A follicle is a bunch of cells that surround what? A what? A secondary oocyte. Did you say secondary oocyte? Or primary oocyte? Did you say primary or secondary oocyte? Is that what you said? Yes, Scott, that's exactly what you said. Very good. So a follicle, this is so much fun. A follicle is, what's a follicle? A bunch of cells that surround a primary or a secondary oocyte. I'm getting the hang of this. But usually it's a primary oocyte. Why is it usually a primary oocyte? Yeah, for only 4 hours, it'll house a secondary oocyte. So it's usually a primary oocyte because most of your eggs are what, ladies? Haploid or diploid? Most of your eggs are primary oocytes, and they are indeed what? They're diploid until when? 4 hours before ovulation. 4 hours before ovulation, what magical event occurs? You complete me. We complete meiosis 1, and we start. This guy was arrested where? So this primary oocyte was arrested in prophase 1 from conception would be amazing. I am God, you have ovaries. And that would be amazing. Bunny rabbit. No storks, dude. He's like, it's not? Sorry, man. No, not from conception. The zygote doesn't have follicles, but worth asking about when. What are you? My little primary oocyte. So what are you? So you're an embryo, fetus. What are you? So, yeah, we're going to get there. We're not there yet, but by the time you're a fetus is when you start. Fetus. What's the difference between embryo and fetus? What is it? A day, an hour. Yeah, it's 9. When is it? How crossing over? 9 weeks. Yeah, 9 weeks. We're going to get to that. So embryo versus fetus about 9 weeks. About 9 weeks. Got it? And why? It's because we had to call it something. Y'all don't even know. Like, this whole thing is so sketchy. It's like the time of pregnancy isn't exact by any stretch. Nobody knows, unless it's like, I only had sex once. It was at this day, so now we know. But other than that, and they're not going to ask you when you have sex. They're going to ask you when you missed your period, which could be all kinds of times off. So the whole like days of pregnancy and even the trimesters are all dorked up. You all think this is like some exact science. At 36 weeks, you will pop out that child. No, 38, 39 weeks, it's all dorked up. The bottom line is we're really not that exact. You guys think we are, but we're not. We're like, when'd you miss your, when'd you have, and everybody's different with their periods, so it's never exact. Anyway, so what do we got? We got a primary oocyte. It's going to change to a secondary oocyte 4 hours before ovulation. And that secondary oocyte is going to be in the follicle, right? So that occurs in the follicle. Meiosis 1 gets completed in the follicle. Meiosis 2 starts. And then the secondary oocyte is arrested in metaphase 2. So what does that mean? Metaphase. Metaphase 2. Anybody know something important about metaphase? Can you carry that over? Type. Karyotyping. What is karyotyping? No. Karyotyping just means we take a picture of the DNA. Yeah, and we just take a picture of it. Karyotyping. So when you see DNA, you almost always see it in metaphase. Did you know that? Yeah, that's why I'm taking a second to teach this to you. So in a karyotype, you kind of looking for abnormalities. So you see all these different chromosomes. Some are acentric centromeres, whatever the case may be. And we take a picture in metaphase because that's when it's most controlled, and we can make sure all the DNA is going to be in the picture. So karyotyping, which is basically a picture of the DNA, occurs in what? Metaphase. There's a molecular technique we do in karyotyping. How do you say it? Fish? How do you spell that? Fluorescent immunos in situ hybridization? Fish? Yep. The technique is fish. One of these days you guys will stop me. I doubt it. Fish. What is fish? No. What is fish? What is it? What are you doing? What are you doing? Anybody doing? What is fish? Anybody know what it is? You're fishing. What is it though? Hybridizing to what? To known sequences, but generally to unknown or lack thereof sequences. So oddly enough, fish detects deletions. So a deletion of chromosome 22, possibly. A deletion of chromosome 21, possibly. Or too much. So what fish does is it's basically a radioactive region of DNA or RNA, in this case DNA, that binds to a specific region and lights up. And when it lights up, that means what? You got something, it ain't right. Or if it doesn't light up, that means what? You don't have something. So we use fish for a lot of different things. This is a very common technique in OB-GYN world for detecting chromosome abnormalities. So we should tuck that one away. The fish technique, the first thing you have to do with a fish is you need a what? You need a probe, I agree, but even before that, you need a karyotype. You need a karyotype. So we get a karyotype, and then we stick the probe in there, and if it lights up, is that good or bad?
Yes.
And very good. It depends if you're looking for something. If you're looking for a normal gene and it doesn't light up, is this bad? It's really bad. Are we good with deletions? If you get rid of a couple genes, who needs those ears? We're terrible, man. Because one protein tends to do multiple things in your body. If you have a deletion of a part of chromosome 22, let's say, called, anybody know what that's called? That's that disease. It's actually, this is a good one. Next time around, we name it this one. That's exactly what it's called. No, but actually, it's called the other way around. Okay? Deletion of chromosome 22. Anybody know what that's called, actually? It's actually called, it used to be called DeJour syndrome. But the powers that be, I got to find out how the hell they changed this damn name. But they did. In medicine, there's no such thing as DeJour syndrome anymore. Now it's called what? Deletion of chromosome 22. Why? Because it's a deletion of chromosome 22. I shit you not. DeGeorge, sorry. Dr. DeGeorge, you lost your rights. Maybe it's the French. They got pissed off. I don't know. So I will not have my name on this anymore. So apparently it's deletion of chromosome 22, which we don't do well with, man. They have, when you have deletion of chromosome 22, you have cardiac problems. You have digestive problems. You have respiratory problems. Why? Because one protein or two proteins missing, all kinds of problems exist. Got it? What deletion can we live with?
None.
Pretty much none. Can we live with extra DNA? Yeah. What extra DNA can we live with? So again, we're talking about development, and as we're going through development, I'm going to talk about the issues. That's why we're doing it. And we do a karyotype and metaphase, and that's where we're at. We can live with trisomy 21. What does somi mean? Somi? Somi means what? Stable or unstable. No extra chromosome stable. So that's just single chromosome. Oh, as opposed to what? What is it? Ploidy is accept. So what ploidies are consistent with life? Nothing's compatible with life. What happens if you have a whole extra set? That's a spontaneous miscarriage every time. Trisomy 21 means what? Extra chromosome. No, I want to stick with trisomy 21 for a second because you guys are all a little sketchy on that. I think I've had a problem. Almost every single trisomy 21 is dead is the correct answer. Not viable. So now let me change the question because I didn't expect you to. I kind of thought, I don't know. I wasn't expecting that answer. So not every, so you're all wrong. No, that's right. That's a good answer. So all surviving trisomy 21s are that's what I thought. You were all sketchy. All surviving trisomy 21s, not all, most. The vast majority of what? Sterile? Sterile? Sterile. They're sterile for sure, but that's not what I'm looking for because it's bad. Not complete 21. I don't think you know what you're talking about. No. What? No. Yeah, they do. But they do. But they have all kinds of problems. But that's not the point. All right. I'll give it away.
All have genes that are turned off.
Oh, they do.
So that they're only action.
They do. There's a name for that. Well, that's kind of might be right. If it's an X chromosome. Inactivated, yes, but there's a name for it. We're not. Come on, my little calicos. Calicoism.
Yeah.
Mosaics. Have we heard the word mosaic? I want you to know the word mosaic. Mosaic means we actually can turn off different chromosomes in different cells. So if you have an extra chromosome, what might you do? Turn it off and create what we call a bar body if it's an X chromosome. But we can turn off some of these trisomy 21s in certain cells. We turn them off, and this makes trisomy 21 compatible with life. Do you understand? So almost all trisomy 21s are what? What do you mean by mosaics? What does that mean? One of them got turned off, but sometimes they don't. And does that cause problems? Of course it does. Everybody with me on this? So almost all trisomy 21s that are compatible with life are mosaics. True story. They're not full trisomy 21s. Constitutive of heterochromatin, or would be facultative. What is a bar body? Constitutive or facultative? Well, it's tricky. It's tricky because it's not for that. So listen, constitutive versus hetero. The answer is it's both because it's not for that. Does everybody understand that? Probably not. So let's step back for a second. So people who are XXX, triple X syndrome, are super women. And oddly enough, this is one of the only trisomies that you don't even notice. They can fly and dodge bullets, but that's besides the point. No, and they're Israeli and hot. Really, no one. Wonder Woman, thank you. Wonder Woman, like Miss Israel or something like that. A very good movie. Anyway, so really, no one Wonder Woman? All right, thanks, Mom. So here's the deal. Triple X, they're going to turn off one of the X's, and women are used to turning off the X because you do this anyway. So let's even step back. Let's step way back. Men XY, women XO. No, XX. So if you have a Y, you're a dude, genetically, you understand? So if you're a Y, you're a dude. Who expresses more genes on the X chromosome, men or women? Obviously, they have two of them, so it's the same. Why is it the same? Because you turn one off, and that's called a what? Bar body. So women turn off an X, and that's called a bar body. Can you turn off different X's in different parts of your body? Yeah. Oh, yeah, you can.
Can you control that?
No. It's like, today I think I'll be a cat. Tomorrow, who knows? No, girl, you can't. Watch these blue eyes. Now they're brown. No, you can't do that. But what you can do is know this horrible statement. It's randomly non-random. When did they come up with this shit? What does that mean, dude? Randomly non-random.
Which one is turned on?
Randomly non-random means it's random in the parts of your body, but wherever that part is that it's turned on. So in your liver, all your liver cells will turn off one. So in your liver, if you turned off this one, your whole liver has this one off. You understand? But in your muscle cells, maybe you express this one. And how is it expressed? The bar bodies? Randomly non-random. Does that make sense? I think the terminology sucks, but guess what? That's the terminology that you're expected to know. Randomly non-random means it's random whether your liver is going to have one of those expressed or not, but your whole liver is going to have that same one shut down. Why does that happen? I don't think anybody really knows. No. So you don't know. So none of you answer. What's that? Nah, well, it wouldn't be pluripotency because you haven't differentiated yet. So the bottom line is no, it couldn't be. Now, does it? So my first question was, which they've asked, is who expresses more of the genes from X, a man or a woman? The same because of bar bodies. Everybody cool with that? So bar bodies are, now, a bar body is going to be shut down, the entire DNA. But here's what somebody asked about, is the bar body constitutive or heterochromatin? And the answer is both. And you have to understand why, because it's not in terms of shut down, it's in terms of whether you have genes. So if you have a gene that's never ever, if you have an area of your chromosome that's never expressed and is always just turned off, we call this what? We call this heterochromatin, but we call it constitutive heterochromatin. Why? Because it's always off. There's no genes there. What's a classic example of an area that will never, ever be a gene activated as a gene? Is a centromere. So because this might be turned on in other cells, it would have, if you're going to call it anything, it would have to be what? This whole thing, you would call it chromatin, heterochromatin, but you would call it what kind of chromatin? All right, so we're getting the hang of this. So let's go over this. Step back. Two types of DNA, euchromatin and heterochromatin. Got it? Euchromatin, heterochromatin, what's the difference? Huh? Homework sheet. What? What the? No? Okay. Heterochromatin's wrapped around a histone. That's the difference. You understand? Heterochromatin means it's wrapped around a histone. It's heavy. It's heavy because it's wrapped around histones. What do you know about histones? Positively charged because DNA is negatively charged. Histones have a lot of what amino acids? The basic amino acids. Not just histidine, but it actually has more lysine than histidine. Go figure. So histones, lysosomes, they don't call them that because it sounds like lysosome. So the bottom line is, let's try this again. Heterochromatin versus euchromatin, what's the difference? One's wrapped around a histone. Do you understand? And it's heavier, so we call it heterochromatin. Everybody cool with that? So yeah, that was a little weird. Euchromatin means it's what? Not wrapped around a histone. Now, what's the number one thing that determines whether a gene will get transcribed? If it's wrapped around a histone or not. So that means that euchromatin tends to get expressed. Expressed means get transcribed. Very good. Okay, so now, heterochromatin, euchromatin, heterochromatin is going to be transcribed pretty much never. It can't. By definition, it won't because it's wrapped up around a histone. Euchromatin is transcribed pretty much always. You understand? But now, in each one of the heteros and eus, there's two categories. Got it? The two categories are constitutive and facultative. Facultative means you switch back and forth. So facultative heterochromatin might switch to facultative euchromatin. Everybody understand? It's like an anaerobe or aerobe. Facultative. It can work in either way. Constitutive means always. So constitutive means you're always wound up tight. But it's a little misleading, and I'm going to tell you why. Bar body is an example, and so is replication. Constitutive means you're wrapped up when? I didn't say if you were hetero or you, because you could be constitutive euchromatin and you're never wrapped up. So constitutive just means always. Got it? So constitutive means wrapped up when around the histone? It means either always or never is the correct answer. Do we understand? Good. I don't know why they like to screw with this definition. Okay, so now, constitutive chromatin. When will that be wrapped around a histone? Never. So what is it always doing, constitutive chromatin? It's always being expressed. And these are called what kind of genes? Housekeeping genes. Very good. Housekeeping genes are turned on by what? By nothing, because why? They're always on. Give me an example. Ribosomal proteins are turned on always. When do we make ribosomal proteins up? Always. Because it's from what? DNA. Constitutive euchromatin. EU chromatin, right? Okay, that's good. Now, what about constitutive heterochromatin? That's wrapped up when? Always. So during replication, does the centromere unwind? Oh, you bet your ass it does. Of course it does. Everybody understand? So if it unwinds, what do you call it? Now, see, this is where it gets confusing a little bit, but don't be confused. When I talk about does it unwind, I'm talking about for transcription. All DNA unwinds in replication. You understand? All DNA is going to be pulled off the histone. So that means we have no such thing as these words. Everybody understands? So don't screw that up. And they did ask a weird question about it. So the bottom line is in replication, what DNA is going to be off the histone? Eventually all, because you got to replicate. When you replicate, you got to get off the histone. What do you call that DNA that's off the histone when we're replicating? You have no idea. Is that what you said? You have no idea because you don't know if it was constitutive or what it was. You understand? So, will the centromere ever be off of the histones? The centromere, step back. I always keep stepping back because you guys are a little sketchy. What is the centromere? What is the centromere? Is it protein, carb? What is it? The middle part. It's the part that holds it. What's it comprised of? It's DNA. It's just DNA. It's structural DNA. Do you understand? So a centromere is structural DNA, and it doesn't have to be in the middle. It could be acentric. And the purpose of its structural to hold it on around and wrap around the histones very tightly. So a centromere is just DNA. It's DNA that will never be unwound to transcribe, to be transcribed. It will never be unwound to be transcribed. Everybody understand? That's why we call it constitutive heterochromatin. Will centromeres ever be unwound? Oh, hell yeah, when? Replicating. Everybody understand the difference now? Yeah, they hit that on a question, and I think most of my students got it, but some of y'all got a little nervous on that one, so don't get nervous. Okay, good. We get it now. All right, constitutive heterochromatin. Now, a bar body, does this bar body have any genes on it? Yeah. Does it have centromeres? Yeah. So what's in that bar body? They're inactivated. So, I mean, is it constitutive? It's not really meant for that. You understand? Because you can turn these genes on other places. So the majority of this would be what? The majority of the DNA on this X chromosome would be what? Constitutive hetero or constitutive U? That's what I'm trying to ask. What's the majority in any chromosome? The majority of DNA is surely hell not expressed. Thus, it's not you. So majority is heterochromatin. You understand? And a bar body, we shut it down. So basically, it's not really constitutive heterochromatin because it's kind of the region of DNA that we're talking about. Everybody get the idea? It's the region of DNA. The centromere is a centromere, and centromeres are constitutive heterochromatin no matter what. So what part of the bar body is basically the point? Okay, good. I think we got it. So the bottom line is most trisomy 21s means what? No, Brett. No, that's what we were just talking about, dude. The X inactivation, it's not the same X chromosome in all cells. No, it could be different. That's why it's called mosaics. So in trisomy 21, what happens? Do we shut down one of those trisomy 21s? Always? No. Sometimes? Yeah. If we don't shut down some of them, what's not going to happen? Kid's not born. Everybody understand that? So the majority of living trisomy 21s are mosaics. All right, cool. I think we got that. Just one, dude. Just one. Yeah. What's that? Oh, and triple X? Oh, yeah, they shut down two. Triple X is weird. I don't really understand how they do so well, but they do. Triple X women. I told you. Then they make movies. Wonder Woman. Come Mrs. Israel. All right, trisomy on XXY, XXY, that's one we should know. Who's he? Klinefelter, right? Do they do well?
No.
No. Klinefelters don't do too well. Difference between a mosaic and a bar body. A bar body is specific for an X chromosome you shut down. A mosaic is I shut down this one day, this one in another part of the body. So calico cats are the beautiful example. Calico cats are orange and what? White/black. So orange and white colors. Who's dominant? The orange or white in a calico cat? One's dominant, one's recessive. Which one's which? Whichever one in that area. So in the white patch, what happened? This guy shut this guy down. So the XW in this case becomes a what? Bar body. So in white patches of a calico cat, the white patches, the orange gets shut down. In orange patches, the white gets shut down. So in the white, so what's the bar body in the white? Orange. So bar body is just reserved for X chromosome shutting down because it's pretty common because what? Half the people on the planet are, yeah. What is it? Is it 50-50 to become a boy and a girl? 52-48. It's not 52. It's like 51.8. But anyway, why is it not 50-50? What do we need more? More men or women? We need more men. Why do we need more men? She's like, we need more real men. She's like, you're telling me something? We live in New York. You're not telling me something I don't know? Besides that, why do we need more men? Because we're stupid. Because who lives longer, men or women?
Women.
By how many years? It's like 7 or 8 now, and it's growing. The gap is growing. Why? We're stupid. Because women are evolving and men are devolving. So the point is, why is it not 50-50? Because Y has less DNA and swims faster? Is that really true? It really is true. It really is true. Wait, so they're boy and girl spermies? Is that true? There are boy and girl sperm? Yeah, there are. There's boy sperm that carry X, and there's female sperm that carry X, and there's male sperm that carry Y. Who determines whether it's a boy or girl? The doctor usually does, and it's a blood test or genetic, but no. That's the guy does. Why? So, is it 50-50 yes or no? No, pretty close to it. But you should know that anyway. Okay, back to work. We got a bar body. That should be pretty clear. A mosaic is I turn off one in some cells and I turn off the other in some cells, and it's a mosaic. Yeah.
What's the thing about the male and female sperm? I've never heard of that before.
Okay. The deal is this, dude. He's like, carrying girl sperm. Blowing my mind. Little spermy here, haploid or diploid?
It's a haploid.
Haploid creature. So XY is like trisome, like 21, chromosome 21, 22. All these chromosomes we have, these are homologs. So which one do you want to give this guy, X or Y? Do you give it both?
No.
No, because then it would be a what?
I know it would be a diploid and then.
Well, it wouldn't be a diploid. It would be diploid here. If I gave it both X and Y, it would be a what? It would be a Klinefelter because it's not a creature yet. Well, it's a trisomy. It has potential to be a trisomy. That's what I'm trying to say. So, what do you give it, X or Y?
Oh, like either or.
Either or. Yeah, you're gonna make X sperm, you're gonna make Y sperm. Who swims faster? This guy's a lot lighter, dude. And these little creatures, they're not like little Sherpas carrying heavy shit. They're carrying stuff with this little. What are they powered by? What are spermies powered by? What? Klinefelters? Flagella? Flagella is what makes it move. What's the energy source? ATP is a cop-out. What's the energy source? What's the fuel? Fructose, man. Fructose. Don't you guys remember? Yeah. That sperm are sweet. Exactly. That's interesting that you know that. So, this is usually when I hear, no, they're not. No, they're not. Anyway, so they do have a lot of sperm are very nutritious. They do have a lot of DNA and a lot of protein and a lot of fructose. So fructose, I do want you to know fructose powers spermies. Got it? That's really important to know. Associated the powers to be. Okay, so you get it now, dude?
Yep.
You're not going to give, a copy of 2 copies of 6 or 5. So why do you give 2 copies of the sex chromosomes? Okay, so now back to the business at hand. We're trying to make some babies, get some different genetics going on here at the same time. I like it. So here we go. We release. We got these follicles. What's a follicle? Bunch of cells that surround primary or secondary. Yes, God. So if we become a secondary oocyte, what's going to happen in the next 4 hours? We're going to ovulate. Ovulation happens on what day of the menstrual cycle? Day 14. Ovulation, define. Define. What is it? More specific. Secondary oocyte released into the abdominal cavity. What's that? That's ovulation. Secondary oocyte released into the abdominal cavity. Secondary oocyte, haploid or diploid? It's now haploid. Is it male or female? We don't know. We do know. What's a Karen, X or Y? It's Karen X, man. There's no Y in there. Understand? We don't do that. We don't. Got it? The Y's don't do that. So what's a Karen, X or Y? X. What's it gonna be, a boy or girl? Depends on the dude. All right. Release the secondary oocyte, and then we pick it up by the, what are these tubes called? Fallopian tubes. Is there another name for them? Is it? Ovarian tubes? Is that something real? Yeah, it is. Fallopian tube, ovarian tubes. You should know that. Does this thing have a tail? Does it swim? No. How the hell does it move then? Don't be silly. What's a cilia? What is cilia made up of? One more, the last one. 9 plus 2 arrangement, microtubules. Yeah, microtubules. You should probably know that. Microtubules make up what? Cilia. Oh my God. It's like, and what do? They beat, whoosha, whoosha, like windshield wipers, and they propel it. Unless you're a what? Smokers, baby. When smokers, for some reason, the nicotine in the smoke paralyzes these guys. And what do? They don't do anything. And what happens? He gets stuck there, and if you get some spermies up there, you can implant right there, and then what happens? How do you say it? Ectopic? What does that mean? Anywhere but that. Ectopic preggers means what? We implant. What implants? The blastula. Zygotes don't implant. The blastula implants where? Which we're going to get to, but you should know it. Implants where?
Anywhere but the line.
Anywhere but the uterus. Implants other than uterus. Why? Because the uterus is where you're supposed to? Other than what? Uterus. And so what? Can you grow? Do spermies ever leak out in here? Yes or no? Oh, hell yeah, they will. Can you? What is that right there? That's your abdominal wall. Can the spermies leak out here and the egg just happen to implant right here? Oh, you bet you can. So what? Why's the problem with that?
Internal bleeding.
The uterus is built to grow blood vessels. These are not. Will the blood vessels start to grow to support this creature right here? Well, you bet your ass they will. They're going to grow, and you're going to make little wimpy blood vessels. Is this good or bad? This is bad. So once again, ectopic pregnancy, will this thing grow in your fallopian tube? You bet your ass it will. It'll grow. Will it start dilating blood vessels? Will it start making more blood vessels? Is there a term for that? Making more blood vessels? Angio blood vessels. Genesis making. So angiogenesis. This thing will go under angiogenesis, and then what's going to happen next? It's going to make blood vessels. It's going to make weak blood vessels, and what are they going to do? Yeah, they're going to blow up, and then you're going to die. Yeah, oh, that's a lesion and a half because you're going to internally bleed. Does this happen very quickly? Very quickly. Very quickly. So do we get nervous when a woman has lower abdominal pain and she's in her birthing years? Yeah, we do. Okay, so we go here. We're a zygote at what point? We're still a secondary oocyte. We're a zygote when the first male or female sperm. Are there such a thing? Male, only males. It's my family, only male. Male or female. Do the spermy go everywhere? Spermy go in your hair? Spermy. Do they go everywhere? No, they don't. Why not? Evolution. Studying. They study the brain. There's sperm school. They all go. You will travel this way. How do they know? Do they know which way to go?
Chemotaxis.
Chemotaxis, baby. So you're saying, little girl over here says, "Hey, boys." It sends out a chemical signal, and they know which way to go. True story. Some of them go the wrong way, but you don't want those anyway. Dopey guys. So that's good. So the bottom line is she secretes some chemicals. The sperm most of them start going here, and then booyah! First sperm hits. What happens to that first sperm? Kind of usually dies. So first sperm hits. What causes what? First sperm that hits causes what? Completion of meiosis 2. Where does the completion of meiosis 2 occur? Now, we're in the fallopian tube. Where does the completion of meiosis 2 happen? I know, they just had to repeat what I just said. We're in the fallopian tube. But completion of meiosis 2 happens where? It's still in the fallopian tube, believe it or not. Everybody good? Okay, so we complete meiosis 2. What's your evidence for that? Fission? A little fission? A little fission? A little budding going on? You got a little budding? Yep. So this creature poops out a what? Yeah, so we made a secondary polar body full of what? It's a sac of DNA. Full of what kind of DNA? What is it? Describe the DNA relative to the what that's left. Ovum. Describe the DNA. Presentable. Exactly the same DNA? So this is bad that we don't know this because it's. I'm a little confused. Anybody? Okay, the secondary oocyte was a haploid or diploid cell. Haploid because it had 23 chromosomes. So, true or false, a secondary oocyte has 2 sets of every gene. It's haploid. So it has one. It's not right. It's haploid, dude. Haploid. So it has 2. Hap means 1, doesn't it?
Yeah.
Hap means 1 what? Yeah, y'all need to work on this shit because your mitosis is. We got to go back to like 10th grade. We've been learning this like since the womb, I think. The nurses taught you mitosis, you still don't know it. So listen, the secondary oocyte has sister chromatids, guys. Sister chromatids are exact replicas because you made them when? In S phase. And in meiosis 2, which occurs in the fallopian tube, we split apart the what? Sister chromatids. Everybody understand? So that means that secondary polar body and this ovum have exactly the same DNA. And the answer is, I asked you describe the DNA, and you should have said, it's exactly the same as the ovum because we split sister chromatids. Everybody understand? We had sister chromatids. When we talk about trisomy, monosomies, or ploidy, somy and ploidy is the same thing. When we talk about it, what are we talking about? We don't care about the sister chromatids when we're talking about ploidy number. We care about the centromeres, the number of chromosomes, right? We care about the number of chromosomes. So the number of chromosomes was 23, but each chromosome had 2 sister chromatids. Everybody understand that? So let's try this again. A secondary oocyte is haploid or diploid. Why is it haploid? It has 23 chromosomes. How many copies of each gene does that creature have?
2.
It has 2 copies of each gene, but it's still haploid because they're stuck to the same chromosome. You understand? When does a chromosome become a new chromosome? When does a chromatid become a chromosome? That's a good question. I like that. Adipose. Anaphase. Telophase. That answers. Well, let's go to the question. What's the question? Proteins. Eggs, bananas, fructose. Sperm is sweet. Let's try this again. When does a chromatid become a chromosome? I'll take anything. Correct. When it has its own centromere. What phase does that happen? 100% true. Psyches is bad answer. Bad answer. Anaphase, by definition, is when you split and make a new what? Centromeres. But what anaphase? Anaphase 1 or 2? Anaphase 1 or 2? Not both. So let's try it again. When do you create new centromeres? Anaphase 2 or
Mitosis.
In mitosis, you create no centromeres too. You have to. Everybody understand that? So the answer to the question was, when does a chromatid become a chromosome? And the answer was in anaphase of mitosis or anaphase 2 of meiosis, which is just like mitosis, by the way, which you always hear. Okay, cool. Oh, hell yeah, dude. If you are, well, let's go over this. I guess we're going to go over in a minute, but we'll go over it right now real quick. What's your Ploidy number in anaphase of mitosis? Yeah, 4. He's like, beautiploid. Okay. What's your Ploidy number in anaphase of mitosis? Okie doke. If you don't know this answer, we're a little bit behind in the mitosis meiosis power curve, but that's all right. We're going to fix that. Zach's like, I'll tell you what it is before, but I'm not going to tell you after. Thanks for sharing. So before anaphase, yes, you are a diploid. And if you created new chromosomes after anaphase and beyond, anaphase by definition, you've split your sister chromatids. They're now their own chromosomes. So that means how many chromosomes does any cell have in anaphase of mitosis? Just give me the number of humans for humans here. Are we humans, Scott? Sometimes I wonder. No. Okay. No. Stop. Okay. No. How many chromosomes in a haploid human cell? 23. How many in a diploid human cell? 46. Okay, we're good. We're all on the same page. My next question is, how many chromosomes are in a human cell in anaphase of mitosis? 92 is correct, and we call this creature a what? Tetraploid, and that's something you should kind of know. Okay, good. We're going to do that in a minute, I reckon. All right, back to the business at hand. We made an ovum, and we made a secondary polar body. Tell me about the DNA between an ovum and a secondary polar body. It's the same. Oh, look how smart we had. You guys are like, well, I didn't know what you wanted. The answer. There's only one answer. They're the same. Why is it the same DNA? Come from sister chromatids. When you say you come from sister chromatids, same DNA. All right, now our ovum. If we made an ovum, that's one way to put it. I was thinking you were married and had sex, but that's a different way. Attacked by a sperm is another way, or ejaculated on, I guess, or in would be another way. But attacked by a sperm is an interesting way to put it. So yes, I agree. If you created an ovum, you've been, we can run with that, attacked by a sperm. Everybody clear? Okay. So if you were indeed so lucky to be attacked by a sperm, that means that this guy will complete meiosis to generate a secondary polar body and now be a full-fledged haploid with only one copy of the DNA. Everybody understand? So 1 is your what? Ploidy number, 1N and 1C, because you got rid of, what does the C stand for? You give me something else it stands for. Chromatids. Very good. Number of chromatids. Got it? Is it possible to be 4C? Yeah, when are you 4C? If you're a lady cell, when are you 4C? I'm looking for a name. Oligonium is not right, but that's okay. We're going to figure that out. Yeah, we're going to run through all this because this is just bad. I'm not going to lie. You know, I don't know why it never surprised me. I'm not, and don't feel bad because I've never had a class where all you all know meiosis mitosis well, and I ask these questions, I'm like, yeah, I always wanted to study that better. I knew it for the test. I got the answers right, but then I forgot it all. All right. Oh, shit. So we made an ovum. Now, the ovum hooks up with the sperm, and you make a what? A zygote. And we're going to take a little note to Benny on that. So the ovum plus sperm is a zygote. But it's not when the sperm hits, it's when the DNA fuse. They love that because everything's about definitions in science. So when the gamete DNA fuse, we call it a what? Zygote. Very good. Zygote indeed. Okay, so now let's bang out this oogenesis real quick and spermatogenesis because they're all a little sketchy. Okay, we start with some DNA. Now, what can you tell me about this cell? Can you tell me anything? You tell me a lot of things. What can you tell me? And assume there's a bunch of other chromosomes. What can you tell me? They are not sister chromatids, so please don't tell me that. They can be gametes. Okay, we'll start with 2C. That's something. Okay. Okay, interesting. A lot of weird things here. Okay. Oh, you were supposed to say that I didn't undergo S phase yet. That's what you were supposed to say. What's your evidence that I didn't undergo S phase yet? Because there's no sister chromatids. That's the first thing you should have noticed. Everybody understand? You're supposed to say that they look like homologs, and you say, oh, they're the same. I'll be like, yeah, they're the same. So they're homologs. So these are homologs. Stop. What's that extra piece? Artifact. So the bottom line is, these are homologs, and they haven't undergone what? SAs. What's your evidence for that? The no sister chromatids. What phase of the cell cycle am I in?
Or G0.
Good. I'm in G0. I'm in G1. Everybody understand? But I'm sure as hell not after S phase, right? So now, everybody with me on this. They like to show different karyotypes. Where do you get a karyotype from? Metaphase. Should you know that? Yeah, they asked that. How the hell do you guys know that? Did anybody ever learn that?
Yeah, actually.
You learned it in school?
Yeah.
She's like, no, I was hanging out one day. I heard somebody yell it. You learned it in school?
Yeah.
That's good. You should know it. They actually asked that. I don't know how. I honestly don't know how you would know that other than just learn it. Does it make any sense? No. I guess because it kind of makes a little sense because they're most organized. They're set up. I mean, that's when we do it. But they asked that, so now you know it. Don't learn it ever. Okay, so here we go. We have these two homologs, and in a woman, we're going to call these oogonium. So are these gametes? Yeah, they're gametes. Gametes can be diploid, guys. And should you know that? Yeah. Now, this oogonium, how old are we?
Not born.
Not born. We're negative.
9:38.
Somewhere between 9 and 38 weeks, and it's actually pretty early. It's like 12 to, I think maybe 12 to 14 weeks. Ladies start making oogonium. So by 12 weeks, you got some good sperm cells. Maybe even by 9. So what are we called when we're making oogonium, ladies and gentlemen? What are we called? We're a fetus because we're a fetus after 9 weeks. So the fetus makes oogonium. True or false? Yes, that's why I'm writing it. Fetus makes oogonium. Now, my question for you is this. What happens to my oogonium? And there goes mitosis or meiosis. So it undergoes mitosis and meiosis both. Because this is always amazing when you guys be like, oogonium, meiosis. It's like, I have this one egg. It's going to split, and it's going to make one ovum, and I got that the rest of my life. Ooh, what lucky guy. No, it doesn't work that way. This oogonium's going to go a lot of what? A whole shit ton of mitosis. And then some of the oogoniums are going to get triggered on to go what? Meiosis. Everybody understand that? So don't screw that up either. So oogonium, they asked this question. Yes, they did. Oogonium undergo mitosis or meiosis? Yes, Scott is correct. Everybody understand? I like it. Now, let's say we made a bunch of these oogoniums. What's going to happen to oogonium next? It's undergo what? S phase. What's your evidence that it underwent S phase? Sister chromatids. Booyah and booyah. Everybody understand? Okay, so, what's the thing called after it underwent S phase? Have a name? Primosite. Good. Primosite. Okay. Now, you guys remember what was the number? Oogonium you're born with? 3.
0.
0.
3, 0.
0.
0. 3 million minus 3 million. Very good. 0. You're born with no oogonium because what happened? Before birth, you, give me the word. Started is not the right word. Differentiated. I'll go with differentiated. Oh, I like that word. You've differentiated into primoroocyte. Do you agree? Please agree. Okay, good. So prior to birth, you differentiated. Not only did you differentiate, now you can say it. You started meiosis 1. You started meiosis 1. And you stopped meiosis 1. You become arrested in where? Prophase 1. So prophase 1 has to trigger something in your brain right away. What's it called? Birth? Okay. No. No. Prophase 1 should say crossing over. So, ladies, for the last 25 or so years for your lives, what's been happening to your DNA in your eggs?
Dying.
Crossing over. Well, they've been dying too. That's true. But they've been crossing over as well. Is this good or bad?
Good.
Yeah. What's advanced maternal age?
If you're 35 and over and pregnant,
35 and over, and we call it what?
advanced maternal age.
Advanced maternal age.
Or elderly multi-gravida.
Elderly multigravida. This is one of the most disgusting terms. You picture like, I'm ready, let's get it on. Elderly, 35 years old. Unbelievable. Elderly multigravida. I really hate that terminology. They really need to
Terrible.
that shit. But that's what it's called. And it says it right on your chart too. Like when you manage patients, you'll see it right on the chart. Elderly multigravida. There's this hot looking 35-year-old, and you're like, am I missing something? All right. Anyway, whatever. So primary oocyte, we do this before birth. We undergo S phase. Now listen. This has how many copies of any given gene? Up here, the Ogonium. 2 copies of any given gene, and it's diploid. The N is for diploid. You should know that. If you want to know the N number, you count the number of centromeres. Everybody understand? Did you change the number of centromeres from here to here? No. And guys, there's how many sets of these chromosomes in a human? 23 sets, right? Not like the book that shows you 2. Never got that. Why did they show all of them? I just picture your textbooks being this tall. You understand? They can't show all 23. You understand? The ... means more. Everybody understand this? So these 2 represent really 46 chromosomes, 23 sets. Are we clear? So we have 23 sets of chromosomes. What are the only homologs that don't match? XY. They don't match. But they do, because they still do what together? Undergo. Oh, let's try this again. XY are homologs because they undergo. I can't even think of something like Y's asked to say. I don't even have anything. No one? The word? No, you wouldn't say disjunction because that's not a real word. They align together in metaphase. That's partly true, but I say they undergo lining up in metaphase. Okay, what? They what? What is that called, dude? The word. Trump's trying to bring back. No. Oh no, he's not bringing. That's already segregation. Segregation. He is. Yeah, he made a new law. We're all segregated by height, by hair. Who knows? So let's try this again. Sorry, Donald. Please don't come to my house again. All right. Don't send the helicopters again. So the bottom line is segregation. What's the definition of segregation? No. When homologs split, we call it what? Segregation. When sister chromatids split, we call it segregation. If they don't split, we don't call it non-segregation. We call it what? Non-disjunction. Powers that be, is an annoying terminology. Segregation makes sense. Non-segregation doesn't exist. They don't call it that. They call it what? Non-disjunction. So when they don't disjoin, what do you call it? Non-disjunction. If they disjoin, do you call it disjoin? No, you call it segregation. Everyone understand? Okay, so let's try this again. What the hell are we talking about? I don't know. How do we get into segregation? Why do we talk about that? X and Y, yes. So why are X and Y homologs? Number 1 is they line up on the metaphase plate together. Number 2 is they segregate during anaphase 1 is exactly what I'm looking for, and that's exactly right. Should you know that? Yeah. For some reason, you guys spaz a little bit with X and Y chromosomes. I don't know why, but you do. Okay, so now we got here, and we call this thing a primary oocyte. This was when? When did you become a primary oocyte? Before birth, right? Not at birth. That's the other thing you guys like. You got 3 million primary oocytes. It's like, bam, magic. As soon as you come out of that badge, it's like, they all switch. It's an on-off switch. It's the light. No. It's the air. Oh. So, before birth, you make 3 million primary oocytes, and then you're born, yes? And then what do? What happens to them next? Nothing. They're waiting until when? First menarche. And what's the average age of first menarche?
11.
5. No, yeah, about somewhere around 12 or so, about 12 years old, somewhere around there. So 12 years old, what happens? You get your period, but before the period comes, what are you getting? You're getting this going on. One of these primary oocytes is going to do what? You complete me. Now, complete meiosis 1. That means that this daughter cell is going to get how much DNA? How many chromosomes? What's the name of the daughter cell? What are the name of the daughter cells from oogenesis 1? primary polar body and a what? A secondary polar body. That would be a problem for the human race. A secondary oocyte is correct. Which one's better? No, you can say it in this case. Why is secondary oocyte better? Because it has DNA. Okay, let's try. They both have DNA. They both have exactly the same amount of DNA. Yes or no?
Same amount, different, like, different.
Same amount. Do they really have the same amount? One of these has X and one of these has Y. Oh, yeah, that's not bad. So the answer is yeah, they have the same amount of DNA, but they have different Y. Certainly different alleles because they have different homologs. So is it the same DNA? Yes or no? Are they clones? No. Would a primary polar body? Would any polar body ever be a clone of another cell? Yeah, we're gonna get to that. Very good. Secondary polar body. So they have true or false. They weigh exactly the same. Yes or no?
Yeah.
Well, there's two. No, it's false, dude. They got organelles. They got proteins. All the organelles, all the proteins come over here. Very few gets here. Get it? Can a primary polar body split? Oh yeah, it can. It can become a secondary polar body. Does it usually? No, but it can. Understand? Have they asked this? Yes. That's what I'm talking about it. So this is called what? Completion of meiosis 1. When did it happen? 4 hours before ovulation, we completed meiosis 1. Now, the next step. Are we destined to make an ovum? Yes or no? Only if the sperm attacks. Right. So if the first sperm attacks, what are you going to do? You complete me. Oh, where were we arrested? We forgot that part. We're arrested in metaphase, so it'd be a good time to get a what? Karyotype. Arrested in metaphase 2. Where does a secondary oocyte complete metaphase 2? Usually in the fallopian tube, provided there's no ectopic pregnancies. I like it. Secondary oocyte completes and becomes a what? Ovum. Ovum. Okay, let's step back. Primary oocyte has how many copies of a given gene? 4 copies. 1, 2, 3, 4. Does everybody see it? What do we call that? 4C for copy number. So the C is either copy number or chromatids. 4C, but there are how many chromosomes in a human? In a human primary oocyte, how many chromosomes? 46 indeed. Everybody understands? So we call that, 46, you're diploid. Now, this little guy over here, the primary polar body, as well as the secondary oocyte, which are on the same level, how many copy number? 2C. It's a fancy 2. And then they're what? 1N. What's the N stand for? It's haploid or euploid. It's the same thing. All right, cool. And then we split again. True or false, the secondary polar body will have exactly the same genes as our ovum. True, because what split? Sister chromatids. So I will ask you this. What is your ploidy number of an ovum? Haploid. And your copy number? 1C. Okay, so my question for you is the following. My question for you is, what's the ploidy number in anaphase 2? What's the ploidy number of a secondary oocyte in anaphase 2? This is when you're like, yeah, that's exactly what I'm like. Where's Tom Brady when I need him? Gee, Scott, I'll teach the class. Probably fucking do it better than me. So, come on, man. What's your damn ploidy number? What are you splitting? All right, stop. Let's take Yitzhak's advice and say before. Before we split, our ploidy number was what? 1. It was a haploid. How many chromosomes were on this plate before we split? 23. Does everybody understand? How many chromatids were on this plate? 46. What is each chromatid destined to become? Its own chromosome. Do we understand? 23 chromosomes. What did I just do? I just did anaphase. Do you understand? I split my sister chromatids. Do we get it? Are there any more chromatids left? No. There are what left? How many chromosomes over here? How many over here? What's your ploidy number in anaphase 2 of oogenesis? 2N. You got 46 chromosomes, guys. You're going to be 2N. It makes sense because this one haploid is going to give rise to two haploids. It must have been a diploid for a moment. What does diploid mean? How many chromosomes for a human? 46. Do we understand? So let me show you some shitty questions in a minute that they asked, and they've done this lots of times before because it's important, I think. Okay. Any questions about that? Please know that. Write that down and be like, I'm supposed to know that you're a diploid in what? Anaphase 2, and you're a tetraploid in anaphase of mitosis. What's your ploidy number in anaphase 1? Is there an anaphase 1? Yeah, there's an anaphase 2. Oh, by the way, what do you not do before meiosis 2 that you do before meiosis 1? Yeah, what? Go through what phase? S phase. There's no S phase, and they asked that. And you kind of should know that. It's kind of logical, but at least you heard it. There's no S phase before meiosis 2, right? Okay, so then step back. What is your ploidy number in anaphase 1? What's your ploidy number in metaphase before you split? What's your ploidy number? 2N. So what's your ploidy number after? 2N, because you didn't split any what? Centromeres. You split the chromosomes, but you didn't split any. Everybody understand that? Please know that. So basically, write down, I'm supposed to know the ploidy. I can't keep spending time on this shit. We got a lot to cover. I got to know the ploidy number in anaphase 1 and 2 and in mitosis. Got it? In all those anaphases, I got to know the ploidy number and actually understand it. Got it? Go ahead.
What are the different things that C can stand for?
Copy number or chromatin. C is copy number and chromatin. Yeah, diploid in anaphase 1. I agree. And the 4. Okay, Ruby. Now, here's a question. Let's say you had something like 2N equal 50. How many chromosomes in anaphase 2 of this creature? This is kind of shit they told you, understand? So associated with a human, it usually helps. So what was the question? I don't remember what I asked. Like I really don't.
How many
Chromosomes and anaphase.
Chromosomes in anaphase 2. Do it. How many chromosomes in anaphase 2? I thought primary polybody secondary oocyte had the same amount of DNA. They do have the same amount of DNA. What's the problem, Allie? Primary polybody and secondary oocyte?
They
Good.
don't weigh the same though.
Oh, they do weigh the same because the X and Y are a little different. No, don't they won't get that bad. Okay, good. So, chromosome, how many, what's your ploidy, what did I say? How many what? What's your ploidy number in?
Chromosomes.
Is it the same thing? In anaphase 2, what's your ploidy number? How many chromosomes? 50 chromosomes, you think? Sure? Yeah, good. So in anaphase 2, we are what creature? What are we a creature in anaphase 2? What kind of creature? Haploid, diploid, tetraploid? We're a diploid. And diploid in this creature means 2N equals 50. So the answer is 50. In mitosis for this creature, how many chromosomes in the cell? What part of mitosis is the correct answer? Got it? In PMAT, prophase, metaphase, anaphase, telophase, PMAT. Let's run it. Give me the digits, baby. How many chromosomes for this creature in mitosis? Go. 3? 350?
Yeah.
How many chromosomes? 50. How many chromosomes? 50, apparently not. 50. How many chromosomes metaphase? 50. How many metaphase? 50. 100. Why? 100. Why? Because you have to become a tetraploid before you can become. I understand it. So that's the kind of thing they do, which for some reason actually worked pretty well for you guys.
So it's 50 until cytokinesis, right? I mean, 100 until basically, right?
What's the last part of telophase? Cytokinesis. What is cytokinesis? What starts to form in anaphase, early anaphase? What starts to form? Cleavage furrow. What's a cleavage furrow? Cleavage furrow is from actin. Actin starts to pinch, and then booyah, we just did what? Cleave them. Yes, I agree. You should probably know that. So early anaphase, you get a cleavage furrow, actin bands, and then by the time cytokinesis occurs, you split, and now you have two what kind of cells? If it's mitosis, two what? Identical diploid cells. Very good. I think you guys did pretty well with that. For some reason, I don't know. This is Allie's got this all screwed up back there. Allie S. First. So let's figure out what the hell her problem is here. But okay, let's run it real quick. So we start with oogonium. Let's do spermatogoniums real quick because spermatogoniums are actually truly meiosis. Ladies, you do some weird shit. Are we surprised? No. Because they're very much more complicated than we are. Hormonally, we are not. So what happens? If we're doing what are we going to start with a sperm called what? A spermatogonium is haploid or diploid. A spermatogonium, so get it this time around. Spermatogonium is diploid, yes? And what happens to a spermatogonium? It undergoes what? Mitosis or meiosis? Yes, very good. Where's that happen? Not yet. In your ears? Want to know? Where's it happen? In the testicles? Or in the, what of the testicles? Seminiferous tubules, right? So this spermatogonium, this whole process, as a matter of fact, called what? Where do we make mature sperm? In the epididymis. Should you know that? You better know that. What's 7-up? We should know 7-up, right? Seminiferous tubules. In the seminiferous tubules, we make what? And these are in your testicles, seminiferous tubules. What's the E? Epididymis. What does the epididymis make? Immature sperm, right? Mature sperm, and it makes tails. So what's it going to add? Flagella. We're going to make tails. Vas deferens is going to lead to the what? Ejaculatory duct, and the ejaculatory duct leads to the urethra. The end is nothing. Urethra. What's up with the urethra? What's weird about the urethra? And P is a penis. Ejaculatory duct. What's weird about the urethra? Carries what? Sperm and urine. Is urine is urine sterile? Oh hell, it better be. It better damn well be sterile. If urine's not sterile, you got a UTI. So no, yeah, urine is definitely sterile. So she could pee on your cuts. No, don't pee on your cut. Don't pee on your cut. Use something else to clean it. But if you had to. Anyway, seminiferous tubule. What happens there? Spermatogenesis. That's what we're trying to do right now. Spermatogenesis. What's the product of spermatogenesis? 4 spermatids, 4 haploid 1C cells, which we're going to see right now. Okay, so what happens? First thing with spermatogonium, what do you got to do to them? Mitosis, replicate them, get a bunch of them, and then what are you going to do? We're going to go under S phase, and after S phase, they become what? Primary spermatocytes. Does this look familiar? Yeah, we just did it. And they like to do the difference. What's the difference here? How would you recognize a primary spermatocyte? It's going to be what? It's going to be 4C and what? 2N. 4C because there's 4 copies of the genes. 2N because it's diploid. Everybody got it? You know. Now, these are called primary spermatocytes, yes? Primary spermatocyte is going to split into what? What kind of polar body? No polar body. Dudes don't make polar bodies. They make 2 what? Secondary spermatocytes. Now, are these exactly the same DNA, yes or no? No. How many chromosomes in this secondary spermatocyte to human? 23. How many over here? 23, I understand. What lined up the plate in metaphase 1? No. Why don't you guys know this name? What's that thing called? That's a tetrad. A tetrad. 2 homologs stuck together. What's it called? Tetrad. When do tetrads form? Prophase 1. Prophase 1. Anytime you have a tetrad, you can have what event occurring? Crossing over. We'll get to that in a second. So, secondary spermatocytes, what's their ploidy number? 1N, and how many copies of a gene? 2 copies of the gene. Everybody understand? Who's taking his role in the woman? Primary polar body. So primary polar body and secondary spermatocyte have the same DNA, yes or no? No, they have the same amount of DNA. Everybody understand that? Okay, everybody cool with that? Should be exactly the same picture I just drew a minute ago. I think it is. I don't know what's going on back there. All right, so now, which one's going to split? Both of them are going to split. They're going to become what? Spermatids. How many are you making? 4 spermatids. Are they exact replicas of each other? 2 are and 2 are, but 2 aren't. Everybody understand? And we call them what? 1C, 1N. Everybody understand? And now those little spermatids are ready to become spermatozoa. Spermatid. There's like 5 stages, but for whatever reason, they just want you to know spermatozoa. Spermatozoa are mature spermatids, so where does that happen? Epididymis. Spermatozoa grow some tails and become motile, which occurs in the epididymis. And in the epididymis, they are now full-fledged sperm. Sperm, indeed. And these full-fledged sperm will be stored in the epididymis. Yes, we store our sperm in the epididymis. Everybody understand? What's a vasectomy? You cut the vas deferens. Is that good or bad? It depends what you want to do with life. I agree. So if you cut the vas deferens, do you still ejaculate? Oh, you do. You do. There's just no spermies. So you're shooting blanks. Got it? What are you shooting? No, the fructose. That would be bad. Cotton candy. No. If you cut, no, you don't shoot fructose. What are you shooting if you cut the vas deferens? You still ejaculate, but what's in the ejaculate fluid? What is it?
It's like you're like seminal fluid.
Seminal fluid, but seminal fluid usually includes fructose. But what's not in there? There's no sperm in there. What's in there? What's in seminal fluid, I guess, is kind of the point. Base, yes. There's basicity. So there's a light base in there. Why? Neutralize the acidic vag. Your vag, ladies, is acidic. And guess what? Do spermies live in an acidic environment? Nope. So how do we use that for something? Oh, yes, indeed. Plan B. Plan B changes the acidity, makes your vag a little bit acidic, and what can't the sperm do? They can't implant. Live on is correct. They can't implant. Got it. All right, cool. Any questions about little spermies? Go ahead.
So next to secondary, it says secondary.
Spermatocyte. Primary spermatocyte, secondary spermatocyte. You should know where all this happens, where it occurs, everything else. Okay.
How long can this sperm stay?
72 hours. Yeah, about 3 days your spermies live up there. Yep.
So when does it go from secondary spermatocyte to spermatid?
It's continuous. Oh, so there's a big difference between men and women. We just do it constantly. When? What am I doing right now? I'm making sperm. That's what I'm doing. What are you doing? Watch this. I'm still making sperm. Oh, what about now? Now I'm making sperm. What do we do 24/7? Till when? Yeah, about a little bit after death, too. As creepy as it is. Yeah. So they always got one shot left in them. So just keep that in mind.
So there's no picture representation of the spermatid or spermatozoa.
These are all spermatids.
And spermatozoa.
No, dude, the spermatozoa just grow up. They gain more proteins. They're getting ready to make flagella, but they haven't made a flagella yet. So between a spermatid and a sperm is a what? Spermatozoa. Usually mature means you started making different proteins and you just at a further stage, and we just label it as such. We can differentiate it somehow. Okay, any questions?
Sorry, when the tail is added to a spermatozoa, that's what it is.
When a tail is added to a spermatozoa, you are now a sperm. Where's that happen? In the epididymis. Epididymis is a busy place. Any more questions? You guys want to know a lot about sperm. Very interesting. All right. So what happens to? Do you still make sperm if you have a vasectomy? Yeah. Where do they go? You poop them out? No, you don't poop them out. Where do they go? You ever notice guys swoosh around a lot? They go in your abdominal cavity. They just go in your abdominal cavity, and who eats them? You eat them. You eat the sperm. You have little macrophages that eat them up. So the spermies are just cruising around, You got little macrophages eating them up, and there's supposedly no side effects to that. I wonder. I don't wonder. I don't want to know. All right, moving on. Ever. How do they do a vas deferens? How do they do the vasectomies now? Laser. Yeah. I love this. Don't worry. It's either going to be quick and painless, or your balls are going to get 10 times the size they are. True story. So they shoot, and it's literally, they screw up the laser. So if the laser misses, which it happens only in like 3% of the cases, it's actually 8%. In 8% of the cases, the lasers miss, and they hit part of your testicles, and your testicles. It only lasts like a week, though. And it's supposed to be like, childbirth times a million. Your testicles get this big, and they want to blow up, and it's not fun. Every guy's like, oh. Okay, so you have that. But if you have the other 92%, it's just, and you're done. And you walk out, hey, let's go. Got it? All right, true story. But anyway, so what is in seminal fluid again? It's all about what's not in seminal sperm or not in seminal fluid. You know that. Okay, I'll have to know that. Now, where do we get our genetic diversity from? Oh, what happens in prophase 1 again? Crossing over, because you have what? Tetrads, because the DNA is close together. Can all the tetrads cross over with each other? Or is it just the center two? Yes is an answer that doesn't really make sense. Can all the, or is it just the center two? All of them can. You know what this is called? Anybody? Holiday structure? Have you guys heard the holiday structure? Not one of y'all? That was the worst part of genetics. It's really not that bad. Holiday structure. The holiday structure, don't worry about it. Anyway, bottom line is, can all these guys cross over? Yeah, crossing over. Give me the definition of crossing over. How about translocation? How about equal translocation? How about balanced translocation? Yeah, what would you call a balanced translocation? Very impressive. Got it? Balanced translocation crossing over. So some of mom's genes jumps to dad, some of dad's jumps to mom. Okay, so now let's step back because this is important. How do we get genetic variability in eukaryotes? Number one way. Crossing over. That's like number, I'll give it 3. Crossing over is probably about number 3. What is it? Random mating. Woohoo! No, but yeah, that's for sure. Independent assortment segregation. Independent assortment and segregation. We learned about segregation and crossing over. And then there's one more. Mutations will do it too, won't it? Yeah, mutations will give you some genetic variability, but very low. That's not the biggest way because mutations are probably going to kill you. You're not mating, so they're not perpetuating the genetic variability. Independent assortment and segregation are major ways to get genetic variability. Major ways. But I agree, random mating or not mating with your cousins is a better way, right? Why do we get, let's see how I'm going to word this question. Are you more likely to get a mutation when you mate with your cousin? First of all, is it legal to marry your cousin? Legal? Yeah, it's legal, man. It's actually legal, and illegal in a lot of places, unfortunately. But why will you get more mutations if you mate with your cousin? No? So why is it bad to mate with your cousin?
Usually, if you have the same copy of recessive.
So what are you saying? Do you have recessive disease alleles?
Yes.
Yeah.
Yeah, you do. Are they unlikely? Very unlikely, but you have them. And if you hopefully don't mate with your cousin and you find a mate that's distinctly genetic from you, is it likely she has them in the same place? Very unlikely, unless what? It's in the family. So all in the family. The problem is all in the family is, yeah, you have a recessive allele, and you all have a bunch of recessive alleles. I don't. You guys do. No. Everybody's got recessive alleles, but if you mate some random person who's not related to you, it's very unlikely they have exactly the same recessive allele. Do you understand? Is it possible? Of course it's possible, but it makes a hell of a lot higher possibility if what? You're from the same tribe. That's for sure. So how do we control this? How do we control it? Just random mating, I agree, but there's another way. What is it? It's called the database. Y'all don't know about the database. I know some people know about the database. You know about the database. What's the database? Isn't it amazing? People don't know
All
this.
for genetics.
There's certain populations that have a database, and you actually put your DNA in. Females put your DNA in, and you call up and you say, "Hey, I'm dating number 3726. Am I allowed to?" And they're like, "No, run." And you're like, "Damn." Or you're like, "That makes sense." No wonder we got along so well. So, and this is a very true thing. Like after one date or before the first date, anybody? You call up the database. It's not. This is for a population of Jewish folks, but it's also for Mormons. Mormons have this thing, and the Amish were working on it, but they're a little behind the game in terms of technology. So yeah, but it's a true story. So any set of people where the genetic diversity isn't that great has this. And basically, you call up and you say, "How close? Do we carry the same allele?" And if you carry the same allele, they say, "Don't do it." And people usually listen. I'm sure some people don't. And it doesn't mean you're guaranteed. It just means that you ever taste saxophone. There's a bunch of them. Believe it, it's not just two sax. What's that? Yeah, it happens, man. Without a doubt, it happens. So, anyway, so that's pretty interesting. So, what is independent assortment segregation? We should know this. So, my point was getting back to this, and this was a question they've asked too. So, they asked, "What is the phone number you have to know?" So, they asked, "True or false? Is it more likely that two people who were closely related are going to make more mutations? True or false?" This is false. Then why do you get the problems? It's because of hidden recessive alleles. Everybody understand that. You really need to understand that. And let me ask you a question, because this troubles me. I know we have a stats night. I think it's coming up next week. I know you're all excited. You're bringing popcorn and all that shit. And stats is going to be fast math, too. So when we do stats, it's fast math and stats. But let me ask you this, because this annoys the shit out of me. I hate when they hear this. So, true or false, when you go for a screen, let's say HIV screen, you go for a screen, a positive and negative result are kind of the same thing, like equal probabilities, true or false. So what I mean is this. If you're positive, what's the first thing you do if you're HIV positive? What do you do? What's the first thing you do?
Follow-up exam.
Well, you retest. You get a retest. If you're negative, what do? You don't get a retest. Everybody understand? You don't. You're just negative. So my point is this. If you're negative and keep getting retests, is it the same as if you're positive and keep getting retests? Yes or no? So let me explain to you why this comes about. I have a friend who called me up and said they were positive for something, and it was a chromosome abnormality. And I said, so the first thing I said, I get a damn retest. And they were like, well, the geneticist explained, which those you don't know, my PhD is in molecular genetics. So the geneticist explained to us that, well, if you were negative, would you just keep getting negative until you got a positive? Does anybody see you understand what I'm saying? So if you're positive, what's the first thing you do? You get a retest. If you're negative, you don't get a retest. Is it the same thing, yes or no? Does everybody understand the question? It's a very important question for the MCAT and for stats in general and for life, but for the MCAT as well. Why is it not the same thing? It's not even remotely the same thing.
The false positive rate is a lot higher than the false negative rate.
And a lot higher is a lot higher, like 100 times higher. Do you understand this? So the false positive rate is way higher than the false negative rate. They're not even in the same comparison. So it's appalling that somebody would say that. That's an idiotic statement of a geneticist. I was like, I get livid when I hear like really stupid, incompetent people. And that's like literally stats 101, negative 101.0111. So let's get this straight. Understand what I'm saying. Listen what I'm saying. Or what do you say? So screening tests when you're trying to screen the population, have very few false negatives. In other words, we don't want anybody walking around thinking that they're not diseased and they are. Do you understand that? So our tests, all screening tests, are designed to have like we're talking like 99.999% sensitivity to rule, and we're going to go over sensitivity and specificity. Don't worry about it, but I want you to understand this because this my shit off. It was like yesterday that this happened, and I was like, get the geneticist on the phone, shoot him a new one. Anyway, online fucking genetics degree. I'm gonna tell you what's going on. Anyway, so the bottom line is this. Screening tests are designed to have very, very few false negatives, so you don't send anybody out in the population. Which means if you're negative, you got about a 1 in a million chance that you're not negative. You are negative. But if you're positives, it's we don't mind telling people they're positive because most folks know when you're positive, you get another test. And if that test comes up negative, what does it mean? It was a false positive because false negatives are much more accurate than our false positives. Do we understand this? So is it the same as being positive and negative? Is it the same likelihood if one of them is going to be false? Not even remotely. Does everyone understand this? Literally, this geneticist was in a very reputable practice too, and I kind of lost it. Shut them down. Shut them down. Yeah, they can say whatever the hell they want. All right, I think I like that. That's good. Okay, now crossing over occurs when? From phase 1. Does that add to genetic diversity? Yes or no? A little bit, very little bit. Well, what adds to genetic diversity is this. Now, is that mom or dad's chromosome right there on the left? Is that mom or dad? Could be what? Mom. It couldn't be both. That would be really creepy. It could be either. So, but not both. So it could be either mom or dad's chromosome. So you're saying it's a 50-50 chance that that chromosome was here. So it's a 50-50 chance that they do what? Segregate. That could have been moms or dads, and that could have been. So it's a 50-50 chance that that segregates. That's called the law of segregation. Now, if this was dad's chromosome that segregated here for this chromosome, and this was mom's over here, what effect does that have on this segregation?
None.
Would you say it's completely independent? That's independent assortment. They used to hit this so much because the wording's so screwy. You guys screw these up so much. But please get this down because they'll hit it again for sure. The bottom line is this. Segregation involves one set of homologs. Independent assortment says every segregation is independent of each other. Got it? So that's the difference between independent assortment and segregation. Independent assortment is for what? Multiple homologs, where segregation is for one set. So every segregation is independent of others. What did I just say? Yeah, it's kind of hard not to use the word independent. But man, I'm going to tell you, every day, I'm not shitting you. I know this stuff. I don't know probably as well as anybody there is to know it. And every time they use the wording that I see, I'm like, what? What? They're like, if this thing goes this way and this thing goes north, and you're like, what? The bottom line is the key is always to look for what? One set versus multiple sets. If we're talking about one set, we can only talk about what? Segregation. Just for shits and giggles, is it possible that a sperm can get all of your father's? So is it possible, boys, that you make a sperm that has all your father's DNA? First of all, it's downright creepy. But is it possible? I don't understand that number. Is it possible that all of this sperm was your dad's? All the sperm, all the DNA in that sperm. Is it possible? So what would have to happen? Dad lines up, 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 dad lines up. How many times? 23 times. Very good. You understand? So is it possible that you make a sperm that's all your dad's? Hell yeah, it is. Well, what is the probability? Go. 1 over. 1 over. Okay, that's a good start. The probability is 1 over. And please give me a number that I understand. 2 to 23 is not going to be an answer. So what's the probability that you make a sperm or you make an egg that's exclusively DNA from your mother or your father? What's the probability? The smallest number. No. 1 over 8 million. Where'd you get that from, dude? So what I think you're saying is every chance can either be what? Mom or dad, mom or dad, mom or dad. How many times? So you shouldn't recognize that. They could give you that as an answer, but they likely won't because they want you to understand a little bit of math. But that's 1 over what? That's 1 over 2 to the 3rd times 2 to the 10th. Did everybody agree with that? Squared?
Yeah.
Everybody see it? 2 to 10 is what number?
1024.
1024, which is about 10 cubed. So this is 1 over 8, what? 10 cubed to the second power. So about 1 over 8 million. So is it possible? Is that, what'd y'all do today? Guys, what'd you do? I bet you made about 100 million sperm. So are some of those spermies going to be your dads?
Oh,
Exclusively.
yeah, one.
1 in 8 million. So is it possible
Once a week.
once a week I'm going to make daddy sperm? You make a lot more than $1 million a day. But the bottom line is this. So is it possible that you make a sperm that's all your dad's DNA? Is it likely? It's pretty damn likely that every day you're making one of your dad. So now, is it possible that that's the boy that is going to catch the worm and be the one that makes the zygote? It's possible, but it's what? What's the probability?
Well, it depends how much sperm.
It depends how much sperm is in it. Good question. So in an average ejaculation, maybe you've got, I don't know, 100 million sperm. So what's the probability? 1 in 100 million times 1 in 8 million. So is it likely that you're going to clone your dad in your child? The answer is probably not. And then even still, the other DNA from mama is still, what are we talking about right now? We're talking about genetic diversity. Do you understand what I'm saying? And this is what I'm saying. So is it possible that you basically pass on all your dad's DNA? It's possible, but it's what? It's basically impossible. Does everybody understand this? So we're talking about 1 in 8 million times 1 in 100 million. So we're talking about 1 in 8 billion chance of passing on your dad's DNA. So basically, if you have 8 billion children, it's all the people who've ever lived on the planet. You got a good shot at it. So at one time, I must have. All right. Anyway, I think we got all that. I'm very happy. All right. Now, back to the business at hand. We were a zygote last I checked. And we were haploid or diploid. Diploid. We joined the sperm and the egg and made a like living creature. Is this thing alive, the zygote? Is the sperm alive? Of course the sperm's a living cell. It's not a human?
Yeah.
Why is it not a human yet? It doesn't have surfactant. Good answer. Good answer. Weird, but good. Okay, how does the zygote get bigger? How? Divide. I don't know that word. Like continental divide? I'm not comfortable with that word. What's the question? Branching. Holy shit. It grows arms like Groot. I am Groot.
Excited for the second one.
Me too. No. So what is the question? How does zygote get bigger, man? Mitosis is the right answer. Or binary fission. Same thing. No, it's not the same thing. What's the difference between binary fission and mitosis? You know it. Interesting. Spindle apparatus, guys. Spindle apparatus. Why doesn't binary fission need a spindle apparatus? So?
Separates equal DNA.
Because binary fission isn't worried about tracking 23 chromosomes. Do you understand? In binary fission, you have one circular double-stranded DNA. Wait, is it circular or single-stranded? All DNA is circular, right? Yeah. So prokaryotes have circular double-stranded DNA, and they have how many chromosomes? 1. So are they worried about putting them in, making them in a neat plate and all this other crazy stuff? No. Should we know this? Yeah. So what's the difference between binary fission and mitosis? Spindle apparatus. Besides that, pretty much nothing. It's the same thing. But they tested it. So now, back to the business at hand. Zygotes get bigger by undergoing mitosis, but it's not really mitosis, is it? No, it's not. It's a little different than mitosis. Why? Because in mitosis, we're trying to do, in this case in mitosis, the cells get what? They get smaller and smaller with each mitotic division. Is that weird? It's a little weird because that's not usually what happens. Why is it good that they're getting smaller? Increase what? Surface area to volume ratio. Okay, I'll play along. So, dinosaurs had giant cells or no? They had big cells? Like the size of humans, the cell? No. Why couldn't a dinosaur have the cell that's bigger than ours? How the hell nutrients get around in the cell? Little mopeds, go-karts. What do they got in there? They kind of do, kinesin and diane, but that's not the real. What? How do nutrients get around the cell? Yeah, mostly diffusion, simple diffusion. So how would the center of the cell get any kind of proteins or anything? The answer is it wouldn't. So the point is, all creatures have pretty much the same cell size, and there's a standard what? Surface area to volume ratio. So if you increase the surface area to volume ratio, is that more compatible with a life for that cell? The answer is yeah, you want a good surface area. What's a good way to do that? What has good surface area to volume ratio? Like a sphere? Just like a sphere? Yeah, a sphere. Do we understand? Spheres have a nice surface area to volume ratio. So cells are kind of cuboidal, sphere shaped. Something else. So the bottom line is, why do zygotes? What's different about zygotes when they undergo mitosis is they tend to get a little smaller because they're going to increase their surface area to volume ratio. And I would like you to know that. Being that. What's the question? So something else important about surface area to volume ratio. Actually, two more things. Anybody know? What happens when your surface area to volume ratio decreases? Cells divide. Cells divide. That's a trigger for division. Do we understand? When your surface area to volume ratio gets bigger, that means your volume's getting more large than your surface area, and that means it's time to divide. That's a classic trigger. There's another ratio. Anybody know? Anybody know? Chromosomes to what? To volume ratio. Chromosome to volume ratio, there's a standard chromosome to volume ratio, and what happens when you hit it? You divide. Chromosome to volume ratio is another one. Do you want a high chromosome to volume ratio or a low to divide?
Hi, so there's no divides.
If you have a high, okay, so as the cell progresses, this ratio will do what? Chromosomes stay the same, volume increases, it's time to divide. You understand how to think about this? Chromosomes stay the same, volume increases, it's time to divide. So when will you divide? When this ratio is small. Do we get this? This is a thing you were supposed to learn about in checkpoints. This is a major checkpoint operation. I don't know why you guys don't learn it. Anyway, now you know it. Now I'm happy. Zygotes become what? Morulas. What's a morula? Mulberry? What's a mulberry? No, they're little pies that you make in the South. Nobody had a mulberry before? They look like a vat of grapes. No? Mulberries? Mulberry pie? Actually, utterly nasty. I'm not going to lie. It's a brand of clothes. Why am I not surprised? That I did not know. Now I'm so happy. Gucci Couture or what? Gucci? Anyway. Morulas. What's a morula? It's a mulberry. Everybody seen a mulberry before? I've seen some grapes once. I stepped on it with my feeties. Ew. So, mulberry. It is totipotent. A mulberry is totipotent. A morula is totipotent. What's distinctly noticeable about a morula? It's not hollow. It's very solid. Very good. Very good. What will a morula eventually do? Anywhere from, 16 to 64 cells, we call it a morula. Oddly enough, we can still call it a zygote, even if it's not there, it's one cell. So you can be like 4 cells and still be called a zygote, which is weird. But anyway, morula becomes a what? Blastula. Is that an important creature? So important, because the blastula will be the creature that does what? Yeah, the blastula, well, first thing, it's the one that's going to start hollowing out. And when it hollows out, it makes little cavities called what? Coeloms. If you fill a cavity full of liquid, what do you call that cavity? Coelom filled with fluid. Why am I asking this? It was on the test, and one of my students who I wanted to actually strangle, but I didn't this time, was like, oh my God, they asked. It was a coelom, but it was full of fluid. And I was like, what was the answer? A coelom with fluid? And he's like, yeah, or she, or it. I wasn't sure, it was really unsure. Did you agree? I'm unsure. So it was a coelom full of fluid, and the answer was what? Coelom full of fluid. He's like, but it had fluid. And I'm like, What if it was full of air? I don't know. If it's a hollowed out cavity, it's called a what? Coelom. But what if there's Pepsi Cola in it? Coelom and Pepsi Cola. I don't know. It's really was not happy.
Did you choose that one?
He thinks he did. We'll find out in like 10 more days because it was only 20 days ago. So allegedly. So coelom, blastula makes coeloms. What are some of the coeloms in your body? What do you got? Thoracic cavity, abdominal cavity, your digestive cavity. How about your uterus? Cavities in the brain. Why not? I agree. What is the abdominal? You mean another name for abdominal cavity? The abdominal cavity is not the alimentary canal. That's the tube that runs from your mouth to your butt. What's another name for abdominal cavity? No, dude. Oh my God. Peritoneal, guys. Peritoneal. Your thoracic cavity's up here, and your peritoneal cavity's here. What's your perineum?
Your ass.
It's not your ass.
It's your ass. Wait, you said this before. It's between your.
It's the ABC.
It's between your anus and your genitals. That little area has a name. It's called the perineum. Why am I telling you this? They asked this question. It's like, I guess they were trying to get you with peritoneal cavity. I don't know. But it's like, so between your, if you ever wondered what's between your vagina and your anal butthole, it's called your what? Peritoneal.
No.
Perineum. Can I spell it? I can spell it. Perineum. Like perennials. Comes out every year. They ask some crazy shit. They ask about bones. Every once in a while, they come up with some random bone. I shit you not. And they're just going to be like, what bone is that? That's like, really? How are these people supposed to know this? No, they ask random muscles. They ask all kinds of random shit. Yeah. Oh, without a doubt. They expect you to know when they know it. You'll thank me. It's like, God, you're alive. I know what it is. So anyway. All right, blastula. What else is important about the blastula? Anything else? It does what? It makes yeast? HCG. The blastula makes HCG, which goes where? Nowhere. Which goes where? Nowhere. Yeah. But the blastula is not going to make that HCG goes in the blood because by that time. So let's get this straight. A blastula makes HCG 100% correct, but it's not going in mama's blood. Why? Because we haven't even implanted yet. Let alone the placental fuse, which happens 10 days after what? Fertilization. Are we clear? So HCG going in the blood yet? No. 10 days after fertilization? Yeah. So if you're preggers, what do you do the next day? Get a birth control test? Probably. And what do you do? Or you think you're pregnant? You go out and have the stupid unprotected sex, and what do? You go get a birth control test. What's it going to show? Nothing. This is one of the cases where a false negative is really not right. Got it? So, bottom line is, between ass and vag. Thanks, Aaron. I appreciate it. It's like, I got this one, Scott. Between ass and vag. HCG comes from the blastula, but HCG also comes from the, not mom, no, placenta. And what kind of placental cells? Blastula-derived placental cells, you understand? But it's not a blastula at that point because it further differentiated, you understand? So the HCG that's in the blood of mama comes from the placenta, not from the blastula, because the blastula is long gone by the time that happens. Because you might say it underwent. I agree, but then the next step, we're almost there. Gastrulation, I thought that's what you said. So from blastulation, we become gastrulation. Blastocyst, blastocele, blastula, all the same damn thing, different creatures. Got it? So with mammals, we call them different. Birds, we call them something different, but all the same shit. You see blast, it's the same thing. Gastrulation, which we're going to do next. But I got two more things to cover with blastula. Blastula, it starts to hollow out, becomes a coelom. They love that question. I really don't know why. They just love it. So they like to know when you start filling holes. HCG, that's the Prager's hormone. If you have HCG, you're pregnant. Blastula, or you have a tumor, which there are tumors that make HCG just randomly. But you don't need to know that. Blastula, what else? Anything important about it? It's the one that implants. That's really big. Where's this creature supposed to implant? Down the uterus. About 2/3 way down the uterus, the creature's supposed to implant. True or false, the baby's usually carried upside down. No, baby's up right side up. The baby turns upside down going into the third trimester. Yeah, it's like, woo, I'm coming out. What if the baby's not upside down? What does it come out? Feet first. Is that okay? it's fine. So as long as the no, you don't do a C-section. No, cut it out. Damn it. Get that kid out of there. No. First you try and turn it. Sometimes we don't even turn it. As long as the cord's not wrapped, everything looks good. You take the kid out by the feet. But they say, what's that?
How would you turn it?
You go in
Are you
there.
serious?
Oh yeah, dude.
Like choke the kid.
Dude, your hand, big fat head.
Yeah, going through it.
You know those little kids, they got those big fat heads. Your hand is not much bigger than their head.
Right.
So you go up there and you turn it. Yeah.
Extra.
You feel, and yeah, you go up there as a med student. They're like, put your hands up there, and you're like, and they're like, you feel it, and you're like, yeah, I felt it. What'd you feel? I felt it. Did you feel the cord? Yeah. Was it wrapped? I don't know. I don't know. It's like eye exams. Eye exams for medical students are such a bitch. It's so hard to see in people's eyes and ears too. Like when you're looking at an eye, you got this one little window you can see, and you can see the back of the eye real clear. And everybody's like, "Did you see the vessels?" Everybody's like, "Yeah." I don't know many minutes. So anyway, true story. All right, so back to business. Silos, implants, and what's important about implantation? Something very important about implantation, which is really sketchy. What is it? You're not officially what until implantation occurs.
Oh, baby.
You're not pregnant. You're not pregnant until and what's the significance of that? Abortion. We don't call it an abortion until after what? It implants. So if you have a beautiful blastula and you decide to kill that thing, is that an abortion? That's a miscarriage. You understand? But it's an abortion when what? What's that?
How would you do that?
How would you? Plan B can do it. Yeah. Plan B can do it. Stick a Q-tip up there and stop. Catcher's mitt. No. She's like, catcher's mitt. God, thanks, God. Please do not try that. So, that's actually a better question. So the question was, how would you stop implantation? What was the way they used to do it and still do?
Oh my God.
Well, I won't say hangers. Oh, last thing with the blastula, before I talk to you about what they used to do and still do some places. Blastula switches from what to what? Totipotent to what? Pluripotent. What happens when you start to become pluripotent? What have you started to make? You've been making HCG the whole time. Placenta. Pluripotent means some of your blastula cells have differentiated to become placental cells. Got it? So by this time, a blastula is still implanted. So it doesn't go to gastrulation right away. It's still a blastula, and it starts to make the placenta. Who makes the placenta, mama or baby? Both make baby. Got it? Both make the placenta. And what does the placenta make that's really important? HCG. Well, it'll eventually make estrogen and progesterone, but not initially. Because what's responsible for the estrogen and progesterone initially? Corpus luteum will make progesterone and estrogen. All right. So, I want to tell you that real quick. So here's your uterus. They used to stick metal devices up here. And the metal device would scar the shit out of your uterus. And when you scarred it, you can't implant. What is this? IUD, intrauterine device. This is what they used to do until people would get toxic shock syndrome and all this other nasty stuff. But they still have IUDs. And the principle is that it scars the uterus. And if you scar the uterus, the blastula won't implant.
Is it permanent? Meaning with a...
No, dude. Later, just take it out, But people forget and they leave them in. Ladies forget and they left them in too long and then it would rust and shit. This is back in the 70s. No shit.
Are they not metal?
Oh, no, yeah, of course they're not anymore, but they still do the same thing. Yeah, it's just like, aren't they not using aluminum cans anymore? Yeah, no, they're not using aluminum cans. They're using, they have plastic devices, but the concept is the same. The concept is, but no shit, they started with them being metal and they would rust and people didn't go up there. Y'all just don't know. Wait. I shit you not. My first day of OB-GYN. I'm not gonna lie, guys. I didn't enjoy OB-GYN. I didn't do anything. I'd be like janitor, no problem. No OB-GYN for me. My first day OB-GYN, I go in, and sure as shit enough, I go in there and I'll get the speculum and I'm up. What do I feel? I feel a movable mass. And I'm like, holy shit, you feel a movable mass, you're scared shitless because it's like, and you don't want to go to the attending because the attendings are like, oh, you dumbass, that's just the cervix or something. You're like, this fucking thing's moving. I'm like, holy shit.
Oh my God.
So I'm just like, white and sweaty, and I'm like, I felt something in there. And he's like, what'd you feel, you dumbass? They're like, they really, what fucking mean to you, some of these people? And you're like, Sir, I think it was a movable mass. And he's like, yeah, not a fucking movable mass. What? Go in the doctor to do the thing. And I go back in again. I'm like, sure, this fucking thing's moving. So he comes back and he's like, he's like, all right, I'll be out in a minute. And he's like, YouTube and shit. I'm like, fuck, man. He comes out, he puts his hand there, and he's like, I see his face just go, oh shit.
Oh god.
He pulls out a giant piece of garlic. And he's just like, and I'm just like, y'all know, I served 3 combat tours, and I've seen people blown up. I saw that garlic, and I was like a little girl. Man, I'd be dismissed. And we're like, how long have you had that up there? And she's just like, oh, I forgot about that. And we're just like,
Oh my god.
a lot of folks use garlic, use onions, there's different fruits, and all these holistic ways you can do it, and they leave them up there. And this thing was like so nasty. But that's
What's the purpose?
yeast infections. It gets rid of yeast infections. No, it does not, ladies. Please don't ever use it. Go to a doctor. But yeah, no, it actually there are different vegetables that really work. They really do, and garlic is kind of one of them. True story, but not really. Don't ever do that, please. You'll terrify the med student who has to do that exam. And I got one more. The next day, I shit you not, the next day, I come in and there was this really hardcore woman who wanted to do OB-GYN, and she was tough as hell. And she goes in, and this woman had like cottage cheese all over her vagina. And me and a guy behind us, they're all 3 of us doing this exam, and we're just like, oh. She pulls out the speculum, and she has a mask on. She got splooged. Me and my buddy were just like, OB-GYN. So we hid in the closet for like the next 6 weeks. Anybody want to do the exam? True story. So that's my OB-GYN story. I'm sticking with it. All right, very, very quickly. So we got a gastrulation now. If we're gastralizing, if we're undergoing gastrulation, where are we? What is the creature called? What's it called? At this point, it's a gastrula. So the bottom line is this. A blastula will switch to 2 cell populations, and I want you to know them. A blastula will switch to an ECM, which is called the what? ECM? Extracellular matrix. Let's go with ICBM. Intercontinental missile, ICM. What is it? Intercontinental mass? What is it? Intracranial? No. So, a blastula will become placental cells. And what else? What's this little creature? Inner cell mass. What's the inner cell mass? Yeah, this is the baby. Got it? Inner cell mass. And that becomes a baby. I don't know how that even remotely looks like a baby, but you guys get the idea. We'll put them upside down because you guys think they're upside down for some reason. The smile spreads it up. This is a problem. That's kind of a problem. You might want to. This we can't twitch. You know, like I said, can't turn the head. All right, so gastrulation. So the blastula switches the ICM and the placenta. Understand? The ICM will become the baby. This is, and the placental cells will come the placenta. Placenta cells will fuse with mama cells, and you'll make one giant ass placenta. Everybody got it? Gastrulation. What are the 3 germ layers? The ectoderm, better known as the attracto. Ectoderm, attracto. The mesoderm, which is the what? Means to. You cannot miss this question ever. Means to what? Circulate, reproduce, and what's the last one? Move. And then last but not least, the endoderm, endo for internal organs, right? All right, so almost everything fits pretty well. Well, you got to know the circulatory system. What is it? Quicker. What do you got? Heart, kidneys, one that everybody forgets, spleen. Spleen's part of the circulatory system because it does what? Kills red blood cells. That's just hard. Blood vessels. How about lymph system? Yeah, that too. Yeah, that sounds good. Okay, cool. Circulatory system is important for 2 reasons. Know what it is. Yeah, endoderm is liver. The circulatory system is important because why? It's the first system to develop. By how many weeks do you have a heartbeat? 4 to 5 weeks is plenty of heartbeat going on. Understand? 4 to 5 weeks, the damn thing's beating. Blood vessels fully formed. It's badass. What's that?
That's crazy.
It is crazy. It's absolutely crazy. I agree. So I want you to know the circulatory system because it's the first system to develop. Your kidneys develop early, yes or no? It's part of the circulatory system. The circulatory system is the first system to develop. Your kidneys develop early. What's your evidence? Amniotic fluid. What is that amniotic fluid? Y'all ever drink urine? How many people drank urine? Every one of you drank urine. For how long?
9 months.
About 7, because the first 2 months you didn't make it. But the bottom line is about 7 months you drank urine. Do you understand? It's usually when somebody's like, yeah, I did, Scott. I was in a frat. I thought I was the only one. They're like, dude, I meant like in utero. So, did everybody drink urine in here? You're alive, you drank urine. What's the purpose of the amniotic? What is amniotic fluid made of? About 85% baby urine. You understand? What do y'all think? Like the little kid had a hole and peed out the side of mama? I always wonder where the, or just think maybe the kid didn't pee. The kid pees. So the urine does 2 things. What does it do? It lets you do Pilates during pregnancy, so for protection. And what's the other thing it does? It keeps the alveoli patent, keeps them open, keeps the alveoli open, because the alveoli would stick together because you don't have what yet? Surfactant. Surfactant, when does surfactant come along? 24 weeks. 20 to 24 weeks, you got surfactant. What is surfactant we're going to do now? Surfactant, the significance of surfactant. Surfactant is what? Somebody tell me what it is. It's not a protein. It's a phospholipid. Surfactant's a phospholipid. Your alveoli, which are the terminal ends of your what? Very impressive bronchioles. Your alveoli, which is the terminal end of your bronchioles, are where gas exchange occurs, right? And since there's a high gas exchange, we have a natural lubricant called what? Not no, but hell no. It's called water. Water, surfactant is anything but a lubricant. Water lubricates the alveoli, but that causes a little bit of hydrogen bonding and causes these guys to want to collapse. That collapsing is called what? Atelectasis. So lungs have a tendency to collapse. So what do we need to do? We need to break these hydrogen bonds, disrupt this surface tension with a phospholipid known as what? Surfactant. So at what age do we start making surfactant, folks? 20 to 24 weeks. What's the major significance? This is birth control, right? No, this is what? This is anti-abortion laws. 20 to 24 weeks is where abortion laws stop in the 3rd trimester because of this molecule. Did they know that? No. So kid comes out before 18 weeks. Can it survive? Oh, if you give it surfactant, it'll survive just fine. But is it likely to survive on its own? Not likely because it doesn't have what yet? Surfactant. At 24 weeks, what's normal gestation period? 39 weeks. At 24 weeks, what's the probability a kid could survive? About 95%, guys. 90 to 95% likelihood that a kid could survive at 24 weeks because the kid's got surfactant. Got it? Important? Yeah, I think that's important. Okay, so what is surfactant? Let's review. Phospholipid does what? Breaks hydrogen bonds. Another way to say it is disrupts surface tension of water in the alveoli. Got it? Disrupts surface tension. Prevents what? Lung collapse, atelectasis. Very good. Attractoderm. What's attractive? Your brain. That's attractive. What's attractive? Your nails. Your hair. What else? Nails are attractive. I think they're very attractive. You don't think nails are attractive on a woman? No. What are nails made of? Keratin. Very good. Eyes. Oh, thank you. Yes, I think my eyes are attractive too. Oh, thank you. Anything else? What is? Your anus is attractive? Yeah, we gotta play along. Gotta remember it. Endoderm. What's in the endoderm? The liver, the lungs. What's in the means? Means are a circulatory system. How about your uterus? What is the germ layer it's derived from? Your uterus. Meso, because it helps you reproduce. How about those pretty gonads? Are they attractive? Maybe, but at the end of the day, they're gonna help you reproduce. Move. What helps you move? Muscle, bones. What about the ossicles of the inner ear? What germ layer are they derived from? Ossicles mean what?
Bones.
Little bones. Bones are derived from the mesoderm. Everybody understand you cannot miss this question when they ask you what germ layer is it derived from. You will get it. You own it. You worked it. But what about the hippocampus? That's still the brain. Ectoderm. Don't get screwed up. All right, guys. Peace. I'll see you tomorrow. Don't forget we have class tomorrow night. Tomorrow night I think it's Biochem 1. Ooh, I like that one. Biochem's awesome. I like it, not everything, but almost everything. Biochem's awesome. Peace, guys. See ya. So, Psych 3 is going to be awesome.
Everything.
Everything. Everything.